All right, so today we are going to move on and do section 6.6. This is our second day of transformation, so we're still going to be looking at sine functions and transformations. However, this time we're going to add in this term A. Yesterday we looked at C, our phase shift, and D, our vertical shift. So what do you think A would be? So on here I've already set up Desmos. And we have this A term. Currently it's at 1, C and D are 0. So this would all reduce to y equals sine x. But if I changed A, take a second to think what would happen to this graph. Okay, let's increase it. So you can see we're stretching it vertically. So we have a vertical stretch here. Or you can also think of it as the amplitude as increasing. Right, we're going to make it go down. If it becomes 0, it's just a straight line. And if we go negative, notice we flipped it. So you can see between positive and negative, it flips. And then your amplitude increases again. Your amplitude becomes smaller when you're between 1 and negative 1, right here. So that would be a compression. Either like maybe positive 0.5, negative 0.5, 0.2, 0.8. Okay, so that would be a compression. If it's negative, we call this a reflection because it flips about the x-axis. Okay, so how are we going to actually do this ourselves instead of having Desmos do it for us? Well, we're going to go through that example on the back of our first page. This is the example 1/2 sine of theta plus 90 degrees. We could just make theta x, doesn't matter. All right. So the question is y equals 1/2 the sine of x plus 90 degrees. Now we're still going to have our 5 points. If you remember your 5 points, they're right there on your sheet. 0, 0, 91. These are for just y equals sine x. 180 and 0, 270, -1, and then 360 and 0. Okay, let me make this big, sorry. All right, so these are our 5 points from y equals sine x that we need to transform to get 1/2 sine x plus 90. All right, first we can transform the x coordinate, right, which is our degrees, right here. So if we're adding 90, that means C is actually -90. Remember, it's a reverse sign. So we're moving 90 degrees to the left. So our first point, or the x-coordinate, subtract 90 would be -90. Our second, well, 90 minus 90 would be 0. Our third, 180 minus 90 is just 90. Our fourth, 270 minus 90 is just 180. And our fifth, 360 minus 90 is just 270. Okay, well, what about our y-coordinate? Now, our y-coordinate is affected by two things. By D, our vertical shift, and by A, our stretch or compress. Now, in this case, it's 1/2, so it's being compressed, not stressed. But what we're going to do is multiply every term by A. That's all we have to do. So for example, 0 times 1/2, well, that's still 0. 1 times 1/2, well, that's 1/2. Or if you want, you can do 0.5. 0 times 1/2, it's still 0. Minus 1 times 1/2 is minus 0.5. And again, 0 times 1/2 is still 0. Now, if we did have a D term, which we will have in the next example, you would just do one more transformation where you add D to these points here, but we'll go through that. This one's done. So all you need to do is graph those 5 points and approximate your sine curve. And you will be doing that on the back sheet here. Okay, but I'll post these solutions up with the video as well. Okay, so try that yourself, try graph it. And we are going to move on to question, oh, no, wait, domain and range. Okay, so domain again is just, right over here, all values for x or theta, whichever you want to call it. Range is again all real values for y, but we have a condition. The biggest number is 0.5 and the smallest number is minus 0.5. So we're between 0.5 and minus 0.5. So we're going to write, I'll just write that here, that it's greater than or equal to minus 0.5 and less than or equal to 0.5. So that would be our range. And then the equation of the axis. Right, to find the equation of the axis, you can do it a couple ways. You can take your largest value, add your smallest value, and then divide by 2, so find the average. Or you can just look at what your first value is 0. Right, so your equation of the axis is just y equals 0. Okay, question 2. Question 2 says, write the equation for a sine function that goes through the various transformations indicated. So for A, it says a phase shift of 25 degrees to the right, vertical translation of 3 units up, and it's stretched by a factor of 3. So let me just write this equation, A sine x minus c plus d. So our equation would be, well, it says it's stretched by a factor of 3, so A is going to be 3. And then we have 25 degrees to the right. So if it's to the right, it's positive. So C is positive, but we still have that negative there. So negative, and then we substitute 25. Remember, it's always the opposite sign in the bracket. And then we have a vertical translation of 3 units up. Up is positive, so plus 3. Okay, this is part A. Part B, let's try part B. So if you want, definitely pause the video, try it yourself, and then continue. So take a moment, pause, try B, and now let's do it together. So in this case, we have y equals 35 degrees to the left, vertical translation of 5 units down, and it's compressed by a factor of 0.5. So A is 0.5 or 1/2. It doesn't really matter whether you write 0.5 or 1/2. I just prefer fractions. Times the sine of x. Now it's 35 degrees to the left, so we're going to take the opposite sign. We're going to do positive 35. And then 5 units down, so minus 5. Okay, everyone all right with that? Next, we need the sketch a graph. Part 3. I'm going to start this for you, and then I'll let you finish, and I'll post my solutions. So we have y equals minus 3. I'm going to use x minus 120. Plus 2. All right, so we need our 5 points. I'm going to do the first 2 with you. So that's 0, 0. Okay, and 90 and 1. Then I'll let you do try the other 3 by yourself, and then you can check your work. All right, so first we need to look at the x-coordinate. And that causes a phase shift in the x-coordinate. Now C is a positive value, remember the opposite sign, so C is actually 120. So what we're going to do is add 120 here. So 0 plus 120 is 120. Okay, and then we're going to take this negative 3 and multiply it by our y-coordinate. So 0 times negative 3 is just 0. Okay, but we're not done. We need to do one more transformation in y. The x, we don't need to do anything else. So that's still 120. But then we're going up 2 units, so we need to add 2. So 0 plus 2 is 2. So there's our first point. Let's look at our second point. 90 plus 120 is 210. Okay, 1 times negative 3 is negative 3. Okay, all you have to do is multiply it by that number, and that takes care of both the stretch and the reflection. But then we still have to perform our vertical shift. So our x-coordinate stays the same as 210, and our y-coordinate becomes minus 3 plus 2, which is minus 1. Okay, so definitely try that with the other 3 points and then graph it on the back. Then you can check your answers with what I post, and if you want, definitely use Desmos as well to help you check your answers. All right, so that's it for the lessons this week, but tomorrow I will put on an Explore Learning Gizmo, which is going to go over the translations and transformations of sine functions.